Hello students, today we are going to discuss group 16 of P block. Group 16 contains the element oxygen, sulfur, selenium, tellurium and polonium. Group 16 is commonly called as chalcogens. The meaning of chalcogens is ore forming substances. All the ores that exist, they generally exist in the form of either oxide and sulfide. That is, the elements combine with either oxygen or sulfur to form the ore, and therefore this family group 16 is known as chalcogens. Now if we talk about the occurrence, oxygen, we know it is the most abundant element. Okay, and it forms near about 46.6% of earth crust. Also, we know it occupies near about 21% of atmospheric volume. Sulfur is 16th abundant element in the earth crust. It exists as either sulfides or sulfates, or it is also present in organic matter like in proteins, or in egg, garlic, onion, mustard, etc. All these contain sulfur. Selenium and tellurium exist as selenides or tellurides in their sulfide ore. Polonium is the radioactive element. It is actually metal, and its half-life is approximately 14 days. That means within 14 days it will decay exactly half to its concentration. Let us discuss the general electronic configuration of group 16. As we can note here, the general electronic configuration is ns2np4, where n is the period number. It is either 2 or it can extend up till 6. The chemistry of elements like selenium, tellurium and polonium is a little bit typical because of the presence of d orbital as well as f orbital in their configuration. The next trend is atomic radii. Now if we compare the radii of group 15 elements with group 16, then we'll find that the atomic radii of group 15 element is larger than that of group 16, because we know as we move from left to right in period, the atomic size decreases. But when we move down the group, like when we move down the group in group number 16, when we move from oxygen to polonium, the ionic radii or the atomic radii, it increases. Why? Because there is increase in number of shell. So if we look at the data of atomic radii of these group 16 element, oxygen, we can see it is exceptionally small. These atomic radii are in picometer. So oxygen to sulfur, the atomic radii increases. When we move from sulfur to selenium, atomic radii increases. But now when we are moving forward, the increase in atomic radii is comparatively small. The reason lies in the configuration. In selenium, there will be screening effect of d orbital, in tellurium also, and in case of polonium, it will be the screening effect of 4f orbital, because of which the increase in atomic radii will be comparatively smaller. So, because of screening effect, the increase becomes smaller as we move from selenium to polonium. The next property that we are going to discuss is ionization enthalpy. We know the meaning of ionization enthalpy, that is, it is the energy required to remove the outermost electron from an isolated gaseous atom. Now if we compare the ionization enthalpies of group 15, that is of nitrogen family, with those of group 16, then we'll find that ionization enthalpy of group 15, especially the first ionization enthalpy, is quite higher as compared to that of group 16. The reason lies in the configuration. In group 15, the configuration is NH2NP3. So there is half filled p orbital, which makes them extra stable. And as a result, it becomes difficult to remove the electron. On the other hand, the configuration of group 16 is NH2NP4, so we can easily remove the electron from the outermost shell. As a consequence, group 16 has less ionization enthalpy. For example, nitrogen with its atomic number 7 and configuration 1s2, 2s2, 2p3 has ionization enthalpy of 1402 kilojoule mole inverse, whereas that of oxygen with atomic number 8 and electronic configuration 1s2, 2s2, 2p4, the first ionization enthalpy is 1314 kilojoule mole inverse. But obviously, the second IPs will follow the reverse trend. As we move down the group, ionization enthalpy decreases. That is, as we move from oxygen to polonium, the ionization enthalpy will decrease. The reason? Size increases as we move down the group. Size increases. So what will happen? The number of shell increases. Z effective will also increase. But there will be an important concept that will play its role, that is a shielding effect. And as a result, the outermost electron, they will face least interaction with the nucleus. They can be removed very easily, and therefore as we move down the group, ionization enthalpy decreases. The next property is melting and boiling point. As we move down the group, melting point and boiling point increases. It is because as the size increases, the magnitude of van der Waals forces also increases. And therefore, melting point and boiling point will also increase. But there is an exception. Now, if we look at the information of melting point and boiling point, it is following the trend that the melting point is increasing, boiling point is also increasing. Polonium is an again exception where the melting point is exceptionally small. But the major difference comes in oxygen and sulfur. When we move from oxygen to sulfur, the melting point or the boiling point increases tremendously. It is because oxygen is exceptionally small in size and it exists diatomic. It's a diatomic molecule. It exists as O2. On the other hand, sulfur exists as S8. So, energy required to break the bonds between only 2 atoms or 8 atoms, there will be a great difference, and therefore variation in melting point or boiling point of oxygen and sulfur is exceptionally high. This is your important give reason question. The next property is electron gain enthalpy. Electron gain enthalpy, if it is more negative, the atom will easily gain the electron. Now, the elements of group 16, they have more negative electron gain enthalpy. That means they will easily accept the electrons because of its configuration NS2NP4. But as we move down the group, then electron gain enthalpy becomes less negative, or in other words, I will say the metallic character increases. Oxygen, again it is an exception. Oxygen, on comparison, it has less negative electron gain enthalpy. The reason lies in its small size. Oxygen has configuration 2s to 2p4. So 2p orbital becomes 2p orbital being smaller in size. When the new electrons are added, the electron-electron repulsion increases. And therefore it becomes difficult to add the electron and hence less negative electron gain enthalpy. On the other hand, sulfur has more negative electron gain enthalpy as compared to oxygen. Reason? Its configuration is 3s to 3p4. Now 3p orbital is comparatively larger in size, can easily gain electron, and therefore sulfur has more negative electron gain enthalpy as compared to oxygen. This is again the next important give reason question. Moving on to next property, the elements of group 16, they will have higher value of electronegativity as compared to those of group 15. We know oxygen is second most electronegative element. However, as we move down the group, electronegativity decreases. This is due to increase in size. We know that meaning of electronegativity, it is the tendency to attract the shared pair of electron towards itself. Catenation. What is the meaning of catenation? It is self-linking property. If we discuss group 16 elements, sulfur has higher catenation tendency as compared to that of oxygen. Important give reason question. This is because again the small size of oxygen. If there is a single bond in oxygen atom, there will be total 6 lone pairs. And there will be a great repulsion between these lone pair. And therefore the catenation tendency of sulfur is higher than that of oxygen. If we look at elemental state of group 16 elements, then we'll find that oxygen exists as a gas. This is the most frequently asked question, that why oxygen exists as a gas. It is because oxygen is a diatomic molecule. Now in oxygen molecule, that is when it forms a double bond, we know there is a p-pi overlap. Like we have seen in nitrogen, it forms p-pi overlapping. Similarly, oxygen also forms p-pi overlap. And when it forms p-pi overlap, there is weak van der Waals forces. These weak van der Waals forces are responsible for nature of gaseous state of oxygen. The other elements of group 16, they do not exist as a diatomic molecule. In fact, they exist as polyatomic molecule. For example, sulfur exists as a solid. It exists as S8. Sulfur forms puckered ring structure where it exists in the form of a crown. All 8 molecules of sulfur, they are joined with each other by a single bond and they form a crown-like structure, or they form a W-like structure which is known as puckered ring structure. In your lower classes, you have studied one more structure of sulfur, that was a ring structure. The next property that we are going to discuss is allotropy. All the elements of group 16, they exhibit allotropy. For example, oxygen exists as O2 and O3. So these are the 2 allotropes of oxygen. Sulfur exists in the form of orthorhombic sulfur and monoclinic sulfur. These are allotropes of sulfur. Selenium also exists in the allotropic form like red selenium, black selenium, and there is one more allotrope of selenium, the gray selenium. Gray selenium is the only allotrope of selenium which will conduct electricity. Even tellurium, it also shows allotropic form, but it has comparatively less allotropic structures. Tellurium has only one crystalline form which has a chain structure, and that is similar to gray selenium. So in today's video we have discussed all the properties of group 16 elements. That's all for the day. Thanks for watching. Have a nice day.